So I want you to hold your hand up right now, just right in front of your face, and take a really close look at it.
Yeah, just, move your fingers around a bit.
Notice the fluidity there. Like the motion feels perfectly smooth, the skin is solid, it feels undeniably continuous. We go through our entire lives with this bedrock assumption that reality is a seamless, uninterrupted fabric.
Right, which is completely natural to assume.
Exactly. But what if that is just a highly convincing, biologically ingrained illusion? What if everything you see, everything you feel, and even the flow of time itself is actually a discrete pixelated algorithm flickering incredibly fast?
I mean, that forces a complete rewrite of how we understand existence.
Yeah.
But abandoning that assumption of continuity might actually be the only way out of a century-long deadlock in physics.
Yeah, because for decades we've had general relativity explaining gravity in the macro universe with these beautiful, smooth geometric curves.
And on the flip side, we've had quantum mechanics explaining the subatomic world, which operates in jumpy, discrete packets, or quanta.
And when you try to combine a completely smooth theory with a completely jumpy theory, the math literally breaks down into infinities.
They just absolutely refuse to coexist.
Which brings us directly to the mission of our deep dives today. We're looking at a 2026 paper by Ingham Nasan Jargal called Infinite Fractal Descent, or IFD.
Yeah, and what this paper does is essentially take a side in that fight.
Right. It suggests that to unify physics, we have to let go of the smooth fabric entirely. Reality isn't a continuous stage. It proposes an informational regime where the universe is a discrete, stepped, recursive mathematical graph.
The paradigm shift here is just profound. Traditional physics assumes space-time is a manifold, like a pre-existing container that things exist inside of.
Like a giant empty box?
Exactly. But the IFD model treats space-time as an emergent geometry. There is no empty stage. Reality is a graph that is reconstructed moment by moment by what the paper calls awareness loops within a computational substrate.
So the space between two objects doesn't even exist until the algorithm calculates the relationship between them. Okay, let's unpack this. Because going from the universe is a physical room to the universe is a self-generating graph is a steep conceptual climb.
It really is.
So if we were talking about a universe that is being calculated and built moment by moment, we have to start by understanding the clock driving that calculation.
You do, yeah. And we have to discard our normal perception of time as a flowing river. In the IFD framework, time is the discrete interval between iterations of this universal algorithm.
They call it the universal tick, right?
Yes, the universal tick, represented by the Greek letter phi. Think of it as the base clock, the hidden carrier frequency of everything, and the paper models this mathematically.
Right, with the formula phi of t equals omega 0t plus theta of t.
Exactly. So it's not one single flowing line, but an interplay between two distinct temporal states. You have prime time, which is the foundational absolute frequency, the omega 0t part, and then you have perceived time.
Which is where localized agents register updates with inherent desynchronization. That's the theta of fade, the localized distortion.
Spot on.
Let me throw an analogy out there for you listening to visualize how those two interact. Think of prime time, like the master server of a massive multiplayer video game.
Oh, that's a good way to look at it.
Right.
Yeah.
That server has a global tick rate. It updates the entire state of the game world, say, 60 times a second. That is the absolute objective reality of the system.
But your perceived time is what happens on your specific monitor at home.
Exactly. Depending on your internet connection, you might experience localized lag or jitter. You are slightly out of sync with the master clock, but you are still tethered to it.
That mapping works so well because it highlights the necessity of discrete steps. What's fascinating here is that this incremental dynamic, mathematically represented as S sub t plus 1 equals S sub t plus delta S sub t, perfectly resolves an ancient problem.
You mean the Zeno paradox?
Yes. We all know the classic thought experiment where an arrow in flight supposedly has to pass through an infinite number of halfway points to reach a target.
Which makes motion theoretically impossible in a truly continuous space.
Right. But IFD bypasses this entirely because the arrow isn't sliding through a continuum.
It's literally pixel hopping.
It is executing a series of binary coordinate shifts. The physical state of the arrow is calculated at position A during one universal tick.
And then on the next tick, its spatial coordinates are updated to position B.
Exactly. There is no physical in-between state. The arrow doesn't travel through the intervening space. The system merely deletes its presence at the old coordinates and redraws it at the new ones.
I mean, I understand the mechanism of updating coordinates, but a major question naturally follows that. If movement is just discrete frame updates hopping across a mathematical grid, what creates the physical illusion of heavy, solid objects?
Right, why does anything feel substantial?
Yeah, if a bowling ball and a balloon are both just data being redrawn on a graph, why does one require significantly more physical effort for me to move?
That brings us to the fractal density hypothesis. We are so conditioned to think of mass as an inherent substance, like a fundamental property of matter.
But the IFD model strips that away entirely.
Completely. Mass is redefined as an emergent measure of interaction density. It is simply a ratio of recursive depth, which is n, over a specific spatial volume, v. So according to the formula, m is proportional to n over v.
Wait, so mass is just the universe lagging because it's doing too much math in one spot?
That is a very literal way to translate the formula, yes.
Let's expand on the computer analogy then.
Yeah.
Imagine having a web browser open. If you have a single tab open with plain text, it requires very little processing memory.
The computer runs smoothly.
Right, that's the balloon. But if you open 80 tabs and they are all streaming 4K videos simultaneously, your machine bogs down, the cursor stutters, the cooling fans spin up.
The system is struggling to keep up.
Exactly. That lag, that localized resistance in the system's ability to process the next frame is what we experience as the mass of the bowling ball. It's computational drag.
The beauty of viewing mass as computational drag is how perfectly it maps onto gravitational time dilation.
Because we know from Einstein that time moves measurably slower near a massive object relative to empty space. Under the old continuous model, we just accepted that mass, like Ben's time.
Right. But IFD explains the actual mechanism. The internal awareness loops of that dense object are so thick with iterations that it physically stretches the effective cycle length of the local system. The formula for this is C-roll is approximately C0 times C of rho and V.
So the entire universe is still advancing at the master prime time server tick rate. But the perceived time within that dense gravitational well slows down.
Simply because the local code is too dense. The substrate requires more processing power to compute the local state before it can move to the next frame. Gravity and time dilation are literally just symptoms of the system trying to resolve localized code density.
Okay, I follow the logic that mass is dense code causing system lag.
Yeah.
But I have to push back on the physical sensation of it. When I knock my knuckles against my wooden desk, my brain interprets that as a solid, impenetrable surface.
Right, it feels completely solid.
Yeah, so how does a dense pocket of calculations generate the physical friction of a solid object?
It requires a specific geometric phenomenon that the paper calls the 720-degree orthogonal lock.
A 4D knot, basically.
Yes. For a localized frequency pattern to achieve four-dimensional stability, meaning it persists through time and exerts physical resistance, it has to fold in on itself.
But why 720 degrees? A standard loop or a circle is 360 degrees.
Well, a 360-degree loop exists in a two-dimensional plane, but we operate in a multidimensional construct. So to lock a wave into permanent recursion so it acts as solid matter, it has to circle itself twice.
Through two interlocking orthogonal circles spinning at 90-degree angles to each other.
Exactly. That self-interference is what locks the wavelength in place. It prevents the data from simply dissipating as a linear wave.
Here's where it gets really interesting. This 720-degree knot creates a vertex in the reality graph that we perceive as solid matter. And this leads to a fundamental redefinition of space itself, captured in the paper's bridge equation.
Right, the bridge equation, V equals HF over rho C squared.
The conceptual takeaway there completely upended my understanding of empty space. We treat volume as a rigid box that you can place objects inside.
But the bridge equation demonstrates that volume is mathematically derived from the oscillation pattern itself. Volume isn't an empty container.
Space is just the spatial extent of a coherent oscillation pattern, with Planck's constant h acting as the minimum step size for any change.
Right. An object doesn't sit inside a local volume of space. The vibration of that 720-degree knot generates the localized spatial volume it occupies.
Which means there is no void. But this creates a massive logistical problem for a computational universe. If my hand is a collection of these isolated, self-referencing 720-degree knots, and my desk is a separate collection.
How do they ever interact?
Exactly. If I throw a baseball at a window, how does the universe process the interaction of two completely separate fractal geometries without the software crashing?
It relies on a communication standard the paper refers to as a handshake protocol. Radiation propagates as surface-level wave chains.
So when distinct fractal entities need to interact in the graph, they use electromagnetism.
But IFD doesn't treat electromagnetism merely as a force pushing and pulling. It treats it as a synchronization mechanism, specifically called phase parity matching.
My initial thought reading that was to compare it to a Bluetooth pairing, where two devices have to handshake before they share data.
That's a great analogy.
But how does phase parity actually work mechanically between two physical objects?
Well, to visualize phase parity, imagine two people swinging long jump ropes. If a third person wants to jump in and intertwine a third rope without tangling everything up into a knot, they can't just swing wildly.
Right, that would be a disaster.
They have to carefully watch the rhythm of the first two ropes, match the exact timing, which is the phase, and the direction, which is the parity.
They have to synchronize their subparticle temporal waveforms across different recursive depths, match the frequency before they can occupy the same system.
Exactly. When the baseball approaches the window, their waveforms are operating at different recursive depths. For the collision to actually occur in the reality graph, those waves have to match phases to acknowledge each other's coordinates.
And once that synchronization happens, they interact through parity symmetry breaking transitions.
Right. They form macroscopic excitations or quantized knots of light. When the rhythm synchronizes perfectly, the separate microscopic waves lock together.
They break their individual symmetry and merge into a larger, unified physical event in the graph. The universe validates the collision and calculates the transfer of energy without the code crashing.
It's an incredibly elegant solution.
It really is. Okay, so the system is highly adept at managing these localized collisions. But what happens when this computational system is pushed to an absolute extreme?
You mean when a localized pocket of code becomes infinitely dense?
Yeah. When the recursive depth, n, approaches infinity. Because classical physics breaks down at black holes. We get mathematical infinities where Einstein's equations basically throw their hands up and quit.
Because classical equations require a continuous curve. And you can't infinitely stretch a continuous curve into a single point without dividing by zero.
Right. So how does IFD resolve this?
The IFD model resolves this by capping the recursion. It treats a black hole not as an infinite pit, but as a fractal star, or, more accurately, a computational bottleneck.
A bottleneck. So the system hits a hard limit on its processing power for that specific sector of the graph.
Think of it as a defense mechanism for the universal code. As extreme amounts of dense matter pour into this localized point, the pressure on the local algorithm is immense.
All that heavy, lagging, low-frequency data.
Yes. So to prevent a true infinite loop that would crash the reality graph, the bottleneck actively recycles the data. It forces the subparticles to upconvert their frequency.
Wow. So instead of a black hole being a bottomless pit of gravity, it's more like a cosmic frequency transformer or a file compressor.
That's exactly what it is. It's crushing the data down to save memory.
It recycles low-frequency matter data into high-frequency radiation so the universe doesn't crash, ensuring the absolute conservation of information.
The black hole is just maintaining the stability of the substrate. Nothing is lost. It is merely re-encoded and exported so the universe can keep ticking.
That makes incredible sense. It's an active maintenance protocol. But making that logical leap opens up an even wilder scenario.
Where are you going with this?
Well, if a localized black hole is just a localized upconversion recycling data, what conditions would cause the entire universal system to undergo that upconversion process all at once?
You're describing what traditional cosmology calls the Big Bang. But viewed through the lens of the informational regime, it was not a random, chaotic explosion out of nothingness.
The paper defines it as a universal upconversion, or the big flash.
Right. It was a metric signature change. This was the precise moment that the foundational geometry of our current universe, Minkowski spacetime, was actively generated by the substrate.
And it was driven by a massive, sudden alteration in that global primetime clock we discussed earlier. The paper describes it as a swapping zero and semitone lift in the global tick rate.
A semitone lift. That shift in the master frequency generated an immense cascade of particles and initiated a radiation-dominated phase.
When astronomers measure the cosmic microwave background, the CMB, they aren't just looking at the fading heat of an ancient explosion.
No, they are observing the remnant baseline data of that global clock reset. It is the lingering boot-up sequence of our current operating system.
That reframing is staggering. I mean, we are living inside an actively managed architecture. And if there's a managed system, there has to be a controller governing the parameters.
This is where IFD introduces the creation knob. denoted mathematically as K sub c.
Right, the algorithm parameter that governs how much physical structure is allowed to generate. And when K sub c is set above 1, the system enters a condensation regime.
Exactly. The substrate actively starts recording more fractal folds, accumulating mass, and building the complex structures we see, like stars and galaxies.
But logically, if the system is constantly condensing and building complexity, shouldn't it eventually succumb to entropy? Wouldn't the universe just build itself into unmanageable static?
That is the exact problem that requires a feedback loop. If we connect this to the bigger picture, the paper models a universal controller named Samson V2.
Samson V2.
Yes, it manages the creation knob to prevent the system from dissolving into entropy, and it operates on the exact same principles we use in modern engineering, specifically PID correction.
Proportional integral derivative. We use PID controllers in drones to keep them hovering perfectly level. We use them in basic thermostats.
Samson V2 is the cosmic thermostat. It uses PID correction to genlock the reality graph against entropy, keeping the master clock and the physical output stable.
And it does this by constantly measuring the complexity of the universe, using two very specific metrics: Lumpelziv complexity and permutation entropy.
Let's break those down conceptually. Lumpelziv complexity is essentially a measure of algorithmic compressibility. Think of how a zip file works.
Right, if a file has a highly predictable repeating pattern, it has low entropy and compresses easily.
But if it's completely random static, it has high entropy and can't be compressed. So Samson V2 is constantly checking to see how compressible the universe's data is.
It monitors the permutation entropy, how chaotic the time series data of reality is getting.
Exactly. If the code starts turning into uncompressible static, the Samson V2 controller triggers its PID correction. It modulates the creation knob to enforce order.
So what does this all mean? I mean, directly to you listening to this, it means that if IFD is correct, physics is fundamentally indistinguishable from software engineering.
It really is.
Unifying gravity and quantum mechanics isn't about finding a new physical particle in a giant accelerator. It's about algorithmic frequency control.
This raises an important question. Historically, humanity has played the role of the passive observer. We measure the universe and guess its rules.
But if mass and gravity are just computational drag governed by a creation knob and phase parity,
It implies that humanity might eventually transition from passively observing the universe to actively engineering the reality graph.
we transition from observing to engineering,
Yeah.
which is an exhilarating thought. But before you get too comfortable with the idea of hacking the local physics engine, I want to leave you with one final thought to mull over.
Okay, what is it?
Look at your hand one more time.
Mm.
Move those fingers. We started this deep dive by noting how fluid and continuous it all feels.
Yeah.
But knowing what we've explored today, knowing that you, your hand, the device you're listening to, and the very space you occupy are essentially just localized awareness loops, experiencing localized jitter in a discrete universal algorithm.
That changes everything.
Ask yourself this: what happens to your perception of reality and to your physical existence if someone or something figures out how to manually reach into the code of the substrate, reaches into the code of the substrate and manually turns the creation knob all the way down to 0?
Oh, wow. That is the kind of question that completely changes how you view the empty space in the room around you.
Keep questioning the code. Until next time.